In this video, we'll introduce ourselves to discrete probability. So, the theory of probability plays a crucial role when we make inferences. Intuitively, when we talk of probability, we measure how likely something is to occur. The roots or the origin of probabilities is associated with two French mathematicians, Pierre de Fermat and Blaise Pascal. They were talking about some gamblers in France that wanted to know how to determine the results of an interrupted game, knowing the position of scores of the two equally skilled players at the time of the interruption. So since they want to measure how likely a certain event will occur in that specific game, Pierre de Fermat and Blaise Pascal worked on, and it became the starting point of probability. So, let's get to know some basic terms. First, we have a random experiment. This is also known as a probabilistic experiment or simply an experiment. It is the process by which an observation is made. And once we perform an experiment, exactly one of the many possible outcomes is observed. For example, we have random experiments such as tossing a pair of fair coins, throwing a balanced die, which are classic experiments in probability. And we also have some unconventional experiments such as observing the number of incoming phone calls to a switchboard and determining the amount of dosage that must be given to a patient until the patient reacts positively. So the last two examples of random experiments are more seen in real life, and these are actual random experiments because once we perform these experiments, we have one outcome out of the many possible outcomes. Now, speaking of outcomes, the set of all possible outcomes for a random experiment is what we call the sample space, and we usually denote it by capital letter S. So for example, when we're going to talk about tossing a pair of fair coins, say for example where we will only toss one coin, then this would mean that we're only talking about the possible ways that a coin toss can happen. That can be either it shows up the heads part or the tails part. When we throw a balanced die, when we think of a die, it's a six-sided cube. Well, all cubes are like that, something like that. There you go. So that would mean the possible outcomes of when you throw a die would be 1, 2, 3, 4, 5, and 6. So when we contain these elements in a set, that is what we call a sample space. So when we're going to throw a fair coin, that's just one, we can denote the sample space as having heads and tails. For throwing a balanced die, this can be the sample space containing the elements 1, 2, 3, 4, 5, and 6. Oops, sorry. That should be a brace. So erase that. And there you go. So, observing the number of incoming phone calls to a switchboard, we know that we can have 0 phone calls coming in, 1 phone call coming in, 2 phone calls, 3 phone calls, and so on. So we can also have a sample space with infinitely many outcomes. And more importantly here, if we determine the amount of dosage that must be given to a patient, then of course your sample space will start from 0 dosage and it can be 0.1, even 0.001, and that will be endless. So we can only denote it starting from 0 up until positive infinity. Now, the first three are what we call discrete sample space. A discrete sample space is one that contains either a finite or a countable number of distinct sample points. The sample points are what we call the elements in the sample space. Now, going back here, the sample space of tossing a fair coin and throwing a balanced die are finite. They end up at a certain element. The third one, it's countable although it's infinite because 0, 1, 2, 3, until whatever it ends. We can still count it. However, here, it's not anymore countable because from 0, it can be 0 0.1, 0 0.001, and everything in between. So these three, the first three are what we have, or what we call rather, discrete sample spaces. And this is where most of the time we're going to work with. Now, some other terms. A subset of the sample space of an experiment is what we call an event. So say for example, we have our random experiment here, tossing a coin 3 times. So let's get the sample space of this event. So what are the possible outcomes when you throw a coin 3 times? Well, first, when you throw it 3 times, you get all heads. Another version would be the first two you get a head, the third one you get a tail. Or the first one you get a head, the second one you get a tail, the third one you get a head again. Or you first get a tail, then a head, then another head. Or it can also be you get first a tail, then a head, or then a tail, a head, and a tail, or a head first, then tail, or all tails. So here are all the possible outcomes when you toss a coin 3 times. If we're only going to get a subset, say for example, I'm going to let set E be the set containing the elements head, and tail, and I'm going to let set F be the set containing just head, tail, then I can call set E and set F an event from the sample space because these are subsets from our sample space. Now, if we have an event, it can be simple, wherein if it's a simple event, it only corresponds to one and only one sample point. Just like set F, it only corresponds to the outcome that you have head in the first toss, head in the second toss, and tail in the third toss. So we can classify this as a simple event. But set E has two outcomes, all heads or all tails. And because we can decompose this into more than one simple event, we call set E a compound event. Compound event. So those are the basic terms of probability.